Yeah, yeah. Hide presenter view. Yeah, now this is.
Now, okay.
Yeah, yeah.
So working with the structural analysis, working on structural analysis, we used to take care of all the structure related problem, which covers static structural simulation and transient structural simulations. And these simulations are related to structure related problems like field issues or maybe vibration issues, which occurs during transportation, or maybe some issues occur during drop test or handling issues. We cover all these issues and we have to do the simulation and the testing to validate all these simulations. So, as introduction, you have already aware of this. Earlier, we used to do concept design and then prototype and testing in production. But currently, we have just input one more thing: the simulation. That simulation means currently we have one more tool, MATLAB. We are just we can say that we are going through a concept design, and then we just do make a mathematical model in MATLAB, and then we just go ahead and we just evaluate prior results from that. But simulation gives us a proximate solution of what we want. In simulation, we consider lesser number of assumptions, and we are came near to the approximate solution what we want. It all depends on number of inputs, what kind of variables or inputs are putting. If, for example, material properties and the boundary conditions and the contacts we are giving. So all these factors which we consider in simulation to just reach near to the approximate solution. So these are the working of FEA, how we discretize the model first. So as you see the model, this is the type of meshing in various components we use. For example, for stiff components, we do tria meshing. We do for surface, for example, less thick, the component with less thickness, we used core meshing and all that. So this is a meshing pattern we used. We first discretize it into a small component, and then we make on that basis behind the tool, it is used to make some kind of something. It makes formulation, what kind of formulation we need. All this formulation depends on the type of boundary conditions. And then when we make this uh, this formulation is based on only one element or maybe one node. After that, we assemble all these formulations, and we get after and we just apply boundary condition to this formulation, and then we solve the system. After that, we extract the post processing, we extract the strain, stress, and temperature, whatever we want as output. So we'll directly come to the types of simulation we used to do in appliances in FEA analysis. So first is static structure, transient structural model analysis, model acoustics, random vibration, harmonic, eigenvalue buckling analysis, and dot test analysis. So I'll go one by one to each kind of simulation. I just try to cover in this when in the case studies. So we'll start with the transient structural simulation. In between, if anyone has question, they can ask. So in transient structural simulation, we used to do the measure the impact of impact on the component or appliances during the transportation. When we put any unit, for example, this is the AC outdoor unit, we just put it into the truck. So what will be the impact on the structure inside this? For example, there are piping, fan. If you will see in a pink color, there is a heat exchanger inside this. So, and if this is a cross pattern, you see these are the in blue color, these are the grill. So what will be the impact of transportation in a truck during truck? What will be the impact on the structure during that? So upper body is the EPS. So this is expanded polystyrene, as you see what we say, thermocol or something. EPS you use in packing. So we have to analyze the impact on the structure during the transportation simulation. In this is the power spectral density curve. This is given in a standard value. This is a standard value. We use this value in a simulation, and we just try to extract which component of the unit, maybe it's refrigerator or washing machine, is impacted a lot. So while putting this curve, this whole curve is given by analyzing the road condition of India and overall. For example, this is a standard curve, but we can increase up to 2 times and 3 times. We can increase this value, and we can use this curve in a transportation simulation. This is a random vibration simulation, which is in ANSYS we used to do. Meshing we used to do in hypermesh, and then we just import it. So we just try to analyze which area is impacted. After that, if you see this component, this is a six-axis machine for vibration or random vibration testing, for transportation testing. In this, if you see, these are the supports which hold the unit, and this same PSD curve is imported in this component, and it gives same type of shocks, and we just try to evaluate the simulation result with this final physical results. So this is a method how we do the simulation for random vibration for trucks, or maybe sometimes we just put 1 or 2 units on each one unit on another unit to extract the exact value, because in trucks it is in a stacking condition. So this is how we used to do, and we extract the results, and we just work on that component, and the results are nearly accurate, much accurate, and we can evaluate that how the simulation is helpful in this case. So before going ahead, if anyone has question regarding this.
Mr. Sunil, I think there's no question. Please go ahead.
Okay.
Thank you.
So next one is sound pressure measurement and simulation in model. In this simulation, we used to do model acoustic simulation. In this is a compressor. There was a condition came that during there was sound was coming out coming from the compressor. It's a refrigerator compressor. So they even the design team the proposal was to increase the thickness of the outer shell body from 3 mm to 3.2 mm and 3.2 mm to 3.5 mm. What will be the impact of sound pressure level at certain distance? The distance is mostly as per standard ISO 3740. It should be 1 meter from the center of the compressor. So what will be the sound? What will be the impact on sound if they increase the thickness? So this is one more kind of simulation we can do in ANSYS. It is a modal acoustics, and we can extract the sound pressure level from that. This is a auto spectrum, and the sound, not a sound, sound pressure level we can extract, and we can identify the significant frequencies which are harmful or which can cause disturbance or resonance during actual sound propagation. So after doing this simulation, we just made one more. We just increase the thickness of the shell, and we measure this sound by the mic. This is mic with sound pressure level in a sound lab. So the data was nearly the value was only 1 or 2 dB difference at the same frequency. So this is how we can measure the sound pressure in the simulation model. The next one is piping vibration. In this also, we can measure the natural frequency of a piping. Most of the this is the AC compressor. Most of the compressor you must have seen this kind of bending pipes are there. So you must be amazed at why these pipes are so long. We can reduce up to a certain length. We can directly import. We can directly connect this pipe to here. But because of transportation and because of vibration, it can cause a serious damage, and it can cause a leakage. So this is how we analyze and design the piping to avoid this leakage, and to extract for this we have to extract the natural frequency of this piping. So we extract natural frequency by modeling the compressor and the rubber grommet on the below, and this is the suction discharge pipe. This is the frequency to avoid resonance also. So by adding weight and all that, we can approximate that how much will be the impact of compressor vibration on the body of piping. So because if pipe will vibrate at a higher frequency, or if it got resonance, so it can be leakage or within a month, within a 1 month also. And we can also extract in simulation, we can also extract the life of the piping by,
सुखमन
sorry,
सुखमन सुखमन की चीज सर ने पढ़ी
I think some mic is,
चलो सर मैं नहीं जानता पिया
I think someone's mic is on.
Yeah, please go ahead.
Track the impact at which frequency. Okay, so we can extract the natural frequency and we can extract which frequency has a higher peaks. So in this case, there are two methods. We can extract the natural frequency and we can extract the vibration also. In this, we just put one. I'll give you. I'll show you a case study in the end. I have just hands on that. I'll show you in the end how we extract this. So in this, we just put 1 Newton of force to extract at which frequency the peak should be higher. So this is a method. Another method is we just put load cells on the below in place of rubber grommets and extract the force value, and we put this force value in this, and we extract the exact vibration which we use to we get observed it from the actual testing. So I'll show you it in the end in a hands-on. So this is the physical testing we have done, and we just observe the same frequency as we say in the 32 and 45, and we observe the peak in the same in the physical testing. So this is how we can model and we can correlate the result in the end, because without correlation it can be but for first time we have to make a method. So without correlation it is it's not useful. So after testing, we have observed the same result in simulation and same results in testing. Next one is the pipe bending simulation. It comes under structure bending, static structure simulation. So in this, we have to extract what will be the thickness after pipe should be bent. We done simulation in Altair HyperMesh, and because during the field pipe bender, they used to bend it manually. So there we observed some leakage on the inner side of the piping during bending. So what will be the impact? How much thickness is reduced during bending on the upper side because of tension and lower side because of compression. So we just extract the results in that. So this is the final result. This is what we can do in final result. What is the impact in tension side? The thickness get reduced up to it is 0.6 mm, and it is get reduced up to 0.54, and here on the inner side it gets increased because it gets just squeeze in the inner side, so it gets increased. So what will be the impact during bending in the pipe? So on that basis we just we can increase or decrease the thickness, and what will be the impact during bending. So we can go if we want to for the cost down, if we want to go on the lower side, how much it will be reduced. So this is the way we can do simulation. But in physical testing, we are not able to extract the exact thickness in physical testing. So this is the way we can extract it through the simulation. This is a simulation for a drop test. This is a drop test simulation. In this, I'll show you a video. Video is not playing. Video playing. During drop test, this crisper is getting fall in. If you will see in the first slide, it gets fall from the refrigerator during transportation and even drop test. So by adding some changes in the design, as you see, these are the design changes in iteration 2. We have made these design changes, and these for handling. We made also to make it more stiffer. We made more design changes to avoid falling of this. So in the end, if you'll see in the third and fourth option, we just go with the third option. The falling was get reduced, and in physical testing, it also got avoided during drop test and transportation. So these are the deformation values during drop test. What are the deformation? The red big. We just go in. What are the deformation value near this point? Because this is the if it get deformed more, so it was helping to make it fall in a vertical direction. So